Hello everyone, this is Adnan, and in this lesson we will learn about the concept of limiting reactant. So limiting reactant, before applying it to a chemical equation or learning, about limiting reactant from a chemical perspective, we can relate it, with a real life example. For example, we have a bicycle factory and we are now assembling bicycles, and we make frames and tires in under the same roof. So let's say in the store we have let's say three frames, right? Since it's a bicycle, so it's going to require two tires, and let's say we have three frames, and we have four tires available in the store, right? So since it's a bicycle, so each frame requires two, so we must need at least six tires to assemble three bicycles. But now the problem is that we have three frames, and we have four tires, right? So while assembling, we you can see that as we assemble two bicycles, and here we have already used four tires for two frames. For this third one, now we are short of tires, we don't have tires. So the tires, they got consumed first, right? Or we can say that the tires in this scenario, they are limiting our production, right? So this is exactly what a limiting reactant is. A reactant that gets consumed first in a chemical reaction, or which limits the yield of a product. So I hope this is clear. Let us apply this concept to a chemical equation now. So let's say we have this equation where nitrogen gas is reacting with the hydrogen gas, and they are producing ammonia, NH3. And to balance this equation, I'll have to put 2 here and 3 here. And yeah, so in this case, you can see here that 1 mole of nitrogen is reacting with 3 moles of hydrogen gas, and they're producing 2 moles of ammonia. So these are the standard ratios. As we know that compounds, they react in specific ratios, they don't react randomly. The ratio here is 1 to 3. So for each mole of nitrogen, we must have at least 3 moles of hydrogen gas. Only then we will be able to make 2 moles of ammonia. So that's the standard, right? So remember that in a balanced chemical equation, we do not have a limiting or excess reactant, because the reactants, they react completely, and at the end of the reaction, all of this mass will be consumed, and it will have changed into products. So the concept of limiting and excess reactant doesn't relate to a balanced chemical equation. So limiting reactant or excess reactant, they arise when we react reactants other than the ratios in a balanced chemical equation, when we don't respect this ratio. Let's say, so let me represent the moles of these reactants with a box. So let's say, you see, this is one mole, so I'm going to draw one box. So one box is required to react with three boxes of hydrogen gas to produce two boxes of ammonia. So this is 1:3:2. Okay, now we can clearly see here that if I, let's say I double nitrogen gas, right? So if I'm doubling nitrogen gas from 1 moles to 2 moles, so I must double the hydrogens as well. So in order to react with 2 moles of nitrogen, I must use 6 moles of hydrogen gas. But here I have only 3. So let's say I'm reacting 2 moles of hydrogen, uh, 2 moles of nitrogen gas with 3 moles of hydrogen gas. So what will happen? Will I be able to increase the yield of ammonia? No, it would still be 2 moles. The reason is that we don't have sufficient hydrogen gas here. So because when 1 mole of nitrogen gas will react with 3 moles of hydrogen gas, So this hydrogen, it will be gone, right? So 1 mole of nitrogen is gone, 3 moles of hydrogen is gone according to the balanced equation, and we were able to make 2 moles of ammonia. And now 1 mole of nitrogen gas is left behind as an excess reactant. So here in this case, the reactant the reactant that got consumed first is our is hydrogen, and that is our limiting reactant, right? So, and the reactant that got left behind unreacted is our excess reactant. So in this case, nitrogen is a reactant in excess, and hydrogen gas is our limiting reactant, right? So now let's see what type of questions we can have on this topic on the exam. So they will be, sometimes they give you a balanced chemical equation, sometimes they don't. So you will have to construct, the equation, and you will have to balance it. So I'm gonna, add a balanced equation here. So for example, sodium is reacting with chlorine, and they are producing sodium chloride. And to balance this equation, I will have to put 2 here and 2 here. Now the equation is balanced. So now I can write the question. So let's say I say that 0.28 moles of sodium, react with 0.61 moles of chlorine gas. Find the limiting reactant, right? Find the limiting reactant and the mass of excess reactant left unreacted, right? So this is the question. So let's see how we can identify a limiting reactant, how to solve the question. So this question can be solved in 2 very simple steps. Step 1, you write the standard ratio from the balanced equation. So the standard ratio is 2 to 1. 2 moles of sodium are required to react with 1 mole of chlorine gas completely. So the mole ratio is 2 to 1. But now in the question, they have changed the moles of both the reactants. As I said, the concept of limiting reactant arises when you change, when you don't respect the ratios in the balanced equation, right? So now we have changed the ratios, which may be the same, which may be not. So let's see. So 0.28. So I'm going to write 0.28 moles of sodium here below this 2 from the balanced equation. And the moles of chlorine gas that are given in this question are 0.61. So I'm not going to write this here. I'm going to cross-check this, right? So cross-check. Why am I cross-checking this? Because I don't know that if I'm using 0.28 moles of sodium, how much chlorine is required to react completely with 0.28. This point is very important. I want you to pay attention here. Since 2 moles are required to react with 1 mole of nitrogen, or 1 mole of nitrogen is reacting with 2 moles of sodium. So if we have 0.28 moles of sodium, I don't know what will be the moles of the exact number of moles for chlorine gas to react with 0.28 moles of sodium. So this will I want to cross check this. The actual concentration of the actual amount of chlorine gas may be less than 0.61. It may be more than 0.61. It may be equal to 0.61. I have no idea. So I'm going to cross multiply here to find the value of x. So it will be 0.28 times 1 divided by 2. So this is going to give us 0.14 so moles. So you can see here that we have 0.61, which is more than what is required, right? So I'm going to say, I'm going to write here that after cross-checking, I found that 0.61 is greater than 0.14 moles of chlorine. So this is going to be our excess reactant, right? Chlorine is in excess because it is more than what is required. So when one of the reactant becomes an excess reactant, so automatically the other reactant will be the limiting reactant. This is very important. Let me repeat. In this case, if chlorine is our excess reactant, which we can clearly see, we need 0.14 moles of chlorine in order to react with 0.28 moles of sodium. But we have in the question, the amount that is given to us is 0.61, which is more than 0.14. So this will be left unreacted. It is excess reactant, and sodium will be our limiting reactant because it will get consumed first, right? So now the next part, so I'm going to write Na is a limiting reactant, a limiting reactant. And now the second part of the question of the mass, find the mass of the excess reactant left unreacted. Okay, so similarly, we can see that we have 0.61 moles of chlorine, and we only require 0.14. So I'm going to subtract 0.14 from 0.61. So this is going to give us, sorry, 0.61, yeah, 0.47 moles, right? So the 0.47 moles of chlorine will be left unreacted, and in order to convert this into mass, I'm gonna multiply this with the molar mass of chlorine gas, which is 71, because the formula of chlorine gas is Cl2, and the molar mass of chlorine is 35.5, and so times 2, so this gives us 71 grams per mole. So 0.47 times 71, that's going to give us 33.37 grams, right? So that's the answer. So this is how basically we solve questions on limiting reactant. And I also offer one-to-one online lessons, and group lessons are also available. If you are interested in private tutoring session, you can fill the Google form given in the description, and I'll contact you. So this will be all from my side today. I'll see you in the next one. Take care.